All right, guys, so in this video, we're going to start our unit on factoring, okay? We're going to start with prime factorization for just numbers. We're not going to have any variables included here, just numbers, okay? So just quick definitions, factors, okay? For now, just with numbers, factors are going to be the numbers that multiply to form a product, okay, are going to be considered factors of that product. A number is going to be divisible by those factors. So if we're looking at the number 12 here, factors could be 1 and 12. 1 times 12 gives me 12. So both of these would be considered factors. All right? 2 times 6 equals 12. So 2 and 6 would also be factors of 12. 3 times 4 equals 12. So 3 and 4 are both considered factors of the number 12. Okay? Now, if you'll notice here, I've got 2 times 2 times 3. So these would be what we call the prime factorization, okay, of the number 12. 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. But all these numbers are prime, okay? If you'll look at these other collection of factors, one or more of those factors would not be considered prime, all right? Number 1 is not a prime number, all right? 12 is not a prime number. Okay, 2 is prime, but 6 is not. 3 is prime, but 4 is not, all right? So what we want to do is we want to do the prime factorization. We want to break a number down into only prime factors, all right? Just to go back and redefine the definition of the word prime here. Prime is a number that is divisible by itself and 1. So it's divisible only by 2 numbers, itself and 1, okay? 1 is not divisible by 2 numbers. It's only divisible by 1 number, all right? So that's why 1 is not considered prime, all right? And I'm going to show you how to use a factor tree to come up with the prime factorization here. So let's look at 20. And we could break it down a number of ways, but what I'm going to do first, let's make our factor tree here. So I'm going to break it down as 2 times 10. All right. It doesn't matter which 2 factors you use here first. We're still going to end up with the same prime factorization because there's only one of those. All right. So if you wanted to start with 4 times 5, you would still get the same answer as I'm going to get in just a second. Okay, but I decided to start with 2 times 10. 2 is prime, so I'm going to stop here with that one. 10 is not prime. I can factor that one because it has other factors. So 10 can be broken down as 2 times 5. All right. So when I look at these 3 numbers, all of these are going to be prime. So I've completed my prime factorization. So I want to write my prime factors as a product here. So the prime factorization would be 2 times 2 times 5. All right. All these numbers are prime. So I've completed the problem here, number 1. Right? Let's give number 2 a try here. 63. There's a couple ways to factor 63. The most common way you guys would probably start is 7 times 9. All right. 7 is prime. It doesn't have any factors other than itself and 1. Okay. 9 here can be broken down as 3 times 3. Okay. So just like the number 20, the number 63 is going to have 3 prime factors. I'm going to write them in order. So I'm going to do 3 times 3 times 7. Okay, so this would be the prime factorization for 63. Okay? All right, pause the video here. I've given you a bigger number here to try in number 3, 330. Okay, try to come up with the prime factorization and then come back and check your work. Okay? So I've decided to start by using 33 times 10. I think some of you guys might have started there. You could have done other ways, but 33 times 10 is the way I'm going to go. All right. Well, both of these numbers, for the first time, both of these numbers have more factors. Okay, 33 can be broken down as 3 times 11. Now, both of these are prime, so I can stop on this side. 10 can be factored, like we did earlier, as 2 times 5. Okay, so this one is going to have 4 prime factors. Nothing else can be factored, so I know my factor tree is done. And again, I like to write the factors in ascending order, so I'm going to write it as 2 times 3 times 5 times 11. So this would be the prime factorization for 330, okay? So give the practice problems a try, and then we'll go over those in class.